Ethan? Okay, so what is an antiderivative? An antiderivative is simply the inverse of a derivative. So as you guys remember, when we go from a function to its derivative, for example, we might have a case where we have the function x cubed. What is the derivative of x cubed?
2x.
3x squared. Very good. So the process of doing an antiderivative is simply we're asking the question of how do we go from 3x squared and then go to x cubed? Okay, so there are different ways of writing an antiderivative. The first way is people will frequently use a capital letter. So if we have the function f of x equals 3x squared, then its antiderivative people might label as capital F of x equals x cubed. And what we simply mean by this is that the antiderivative f of x, the antiderivative, is the function such that, yes, Daniel?
Do you just make it uppercase F if you're going backward in derivatives?
Correct.
Like there's no like symbol for it.
There is a symbol for it, and that is the integral. But we're talking about the just one kind of notation first. Okay. So the antiderivative is the function such that the derivative of the antiderivative is the original function. So it's just the inverse derivative. That's all it is. Okay. So for instance, if we have f of x, if we had f of x equals maybe 5x to the fourth, what would be its antiderivative?
20 or x 20.
X to the fifth. Okay. Right? Because if we took the derivative of x to the fifth, we would have gotten 5x to the fourth, right? Well, now I might ask the question, if we had f of x equals just x to the fourth, then what would be its antiderivative?
Maybe. Oh, it's taking the derivative backwards. X to the power of 5. No. Wait, I got it. X to the fourth to the power 5. Oh,
It's a 1/5 x to the fifth. Right? Do we agree with that? Because if we took the derivative of 1/5 x to the fifth, we would get 1/5 times 5 times x to the fourth, which is x to the fourth, right? Okay, so, antiderivatives is really just about trying to rewire our brain so that we're thinking backwards and we can do these derivatives in reverse.
Okay.
So this leads us to an important formula. So memorize this. This is kind of the power rule for antiderivatives.
Is there a product rule?
Hudson, have a seat, please.
Well, stop talking about Don.
It tells us that the antiderivative of x to the n is going to be 1 over n plus 1 times x to the power of n plus 1. Right? So you guys remember power rule, that was x to the n goes to n times x to the n minus 1, right? That's for derivatives. But to go in reverse, it becomes 1 over n plus 1 times x to the n plus 1. Why is that? You can confirm that really easily because the derivative of 1 over n plus 1 times x to the n plus 1, that's just going to be x to the n. Agreed? Because we bring the power out and we multiply the coefficient by that, and then the power becomes reduced by 1 for the derivative.
Yeah.
But for the antiderivative, it's kind of the reverse. The power increases by 1, and we have to multiply by the reciprocal of this power. Okay?
Are you talking about?
We're going to start with this for now. Okay, so don't worry. There is an additional subtlety that is very important, which is that the antiderivative is actually this plus c, where c is a constant, any constant.
What was it without the C?
Without the c is still correct, but we're not getting all the possible solutions. Why is that? That is because anytime we add a constant to a function and we take the derivative, we're still going to get the same thing, right? So if we took the derivative of this plus c, because it's a constant, we're going to get 0, and that's not going to affect the final answer for the derivative, right? And so that means when we take the inverse of the derivative, there are actually an infinite number of solutions, because we're still going to get the same thing if we add a constant. And so that's why we need this plus c. Shh. And if you don't have this plus c, you will lose some points. Okay. So remember, anytime you do an antiderivative, you always add plus c, because the answer remains the same even if you add an additive constant. Any questions so far? It's fine.
Just think I'm taking notes.
Good. Okay, so let me do an example. I'll do another example. So let's say we had suppose you were told that the derivative of f is equal to 3x. What would f of x be? In other words, what is the antiderivative of 3x? So you're given the derivative of f, which is 3x, and you're asked to find what is f of x, meaning that what is the antiderivative of 3x?
X squared cubed.
Any ideas?
Oh,
No.
Okay, ready?
I'll just do it for you guys. This will help us. Okay,
1/3 x to the third.
Guys, none of these answers are correct. Don't worry.
1/3 x to the third. Yeah.
Good. 3/2 x squared. Good. Okay, guys, if you listen, you will understand.
Oh, so
3x is 3 times x to the 1, right? So our n here, our n is 1. Yes? So if we take the antiderivative, this becomes 3 times, right? 1 over n plus 1, which is 1/2. 1/2 times x to the power of 1 plus 1. I'll write it even more clearly. 2 is 1 plus 1.
3/2 x to the square.
Yes, now that's correct. Okay, so you're going to end up getting 3/2 x squared plus c. Without the plus c, it's not totally correct. Okay, and we can confirm this, right? If we went back and took the derivative of 3/2 x squared plus c, we would get 3x. You have to have the plus c. It means that f of x could be any possible value of c. It would still be the same thing. It would still give you the same derivative. So for example, f of x could be 3/2 x squared plus 1, plus 2, plus 3, and the derivative would still be 3x, right? Yeah. Guys, any questions?
Yeah.
Always just add a plus c. Yes. Let me do one more. Guys, I'll do one more. Let's say we had f prime of x equals 7. What would f of x be?
0.
Good, 7x plus c, right? Because we're looking for the function that gives us the derivative of 7.
What's C?
C is any constant. So it could be like 1 or 2 or 3, 2.5. We need it because that gives us all the possible values for f, right? Because the derivative of 7x plus 1 is also 7, right? 7x plus 5, the derivative is also still 7, right? So we need to calculate all of this. Okay, can you guys do 1 and 2 on the classwork? Thank you. 1 and 2.
Yes, is the number. So it's classwork. Oh, it's just three plus eight, right? Wait, what sign we do for that?
Not in this case,
No.
because you're given f prime of x already. Yes.
Well, but I know. So next one would be.
Oh, sorry.
X to the power 4. Over 3, x to the 3, Kelsey. Right, I have no idea. Can you go up so I can do it? Right? F listed something. So if you take 3 out and you get it, so 1 over 2 plus 2 times 1 over what's the original equation this time?
The original equation's here.
You plug in n, so n is 1. It's 2. 2 plus 1. Then, you know, plus 1. 2/3 x to the
Plus c.
Plus c. Whatever. I got it. I got it down, Mr. Knox. You got nothing else. Right for the next stuff.
Are you guys done?
Yeah.
Anybody need more time? You should have gotten 3x plus c and 2/3 x cubed plus c. Any questions, Vincent? Yes, for everything. All right, let's continue. Let's talk about indefinite integrals. The good news is that it's a complicated word, but it means the exact same thing, okay? It's just a different notation. So a different way of writing an antiderivative is by using an indefinite integral. And for this, we're going to be starting to use our integral symbol for the first time. This is fun because it's fun to write, right? The integral. So the indefinite integral is simply an antiderivative. And we write it like this. Let's see. So this symbol here, it's like a long S. It has to extend above and below your line. So write it very tall. And I've seen people write it differently. I like to write it like this. Some people write it like this.
It's the exact same.
It's not the exact same. Personally, I think my way of writing it is more aesthetic.
So you are aesthetic. The words that
Okay. I don't know what that is.
CB bypassing.
Okay. Another thing you need to have is the dx. Okay. The dx, we're going to see the significance of that later, not now, but it has to be there. Integrals don't mean anything if you don't have the dx. And then the thing that you're trying to integrate, so that's the verb form of integral. In the same way that differentiate is the verb form of derivative, integrate is the verb form of integral. The thing you're trying to integrate goes in the middle. So it's sandwiched between the integrand and the dx. Am I even getting these words right? Integrand. I actually said that wrong. The blue thing is the integrand and the red thing is the integral symbol. Doesn't matter, okay? So it's just a different way of writing an antiderivative. So for example, the formula that we just looked at the integral of x to the power of n is going to be 1 over m plus 1 at times x to the power of m plus 1 plus c. So that's the formula I just asked you guys to remember. Okay. Make sure your integrals look nice. Any questions about this notation? Vincent? Dx doesn't mean derivative. You'll see later. Today we don't have enough information to talk about dx yet, but you must have it. Okay. Let me do one more example. Guys, can you be quiet, please? Shh. So, just to get you guys comfortable with using this notation, the integral of x to the fourth. So cannot forget the symbol, and also cannot forget the dx. The integral of x to the fourth, we're going to take the exponent, which is 4. We're going to raise it up by 1, then take the reciprocal of that. So it will be 1/5 times x to the fifth. Okay, so just think about the number that's above 4. So add 1 to it, and then flip it. That's the coefficient, and raise the power by 1.
It's so much easier, Mr. Then.
Okay. Any questions? So the integral of x to the fourth is 1/5 x to the fifth plus c.
Where'd you pull 1/5 out of?
I just said you raise the power by 1 and you take the reciprocal. So 4 plus 1 is 5, and then that gives you 1/5 x to the fifth.
Okay, I get it.
Yes.
Got it. Reciprocal means flip it. I understand.
Yes, reciprocal means. I'll give you guys another example. Let's say we had the integral of square root of x dx. Shh. Quiet. Can you guys? Okay. How would we rewrite the square root of x as a power? Thank you. X to the 1/2. Okay, so then now if we want to apply the formula that we've just used,
2/3.
we're going to raise the power by 1. So that gives us 3/2. And then we have to bring that in front. So it's 1 over 3/2 times x to the power of 3/2 plus c. So that would give us 2 over 3 x to the 3/2 plus c. And that would be our antiderivative or our integral.
I'm getting hungry with stuff. Sorry about that.
Any questions about that?
No, but where did we have
So the first step is always to try to get things in terms of powers or sums of powers. Give you guys one more example. Let's say we had the integral of x squared plus x cubed over the square root of x dx. Any ideas for the first step to do this? Any ideas? Huh? Separate into 2 fractions. Good. So that'll give us x squared over, and now I'm going to rewrite the square root of x as x to the 1/2. Guys, you guys are very chatty. It's kind of annoying.
Tuesday. Welcome Tuesday.
You're forgiven. Okay, so I'm going to split up the fraction into 2 separate fractions, and I'm going to rewrite things in terms of powers. Okay, x squared over x to the 1/2. What is that? X to the 3/2. Very good. X cubed divided by x to the half. Anybody? X to the 5/2. Very good. Okay, and then now we can integrate these 2 things separately because these are just simple powers, right? Any questions about what I did so far, though? 2 minus 1/2 is 3/2, and 3 minus 1/2 is 5/2. All right, what is the integral of x to the 3/2?
Say it one more time and I got it.
What is the integral of x to the 3/2?
I got you. No, give me, I got it.
2/5.
What is it? What? Oh, yeah, yeah.
2/5 x to the power of 5/2.
No, 5/2. That's.
Dang it!
That's good. Okay, how do we get that? So we do 3/2 plus 1, which gives us 5/2, and then we flip it. So take the reciprocal and bring that in front. Huh?
Where's the integral sign?
I'm taking the integral, so I don't have it anymore, right? Okay, integral of x to the 5/2. Anybody?
Interval.
2/7.
Reciprocal.
Very good. 2/7 x to the power of 7/2. Are we done? No. Plus c, right? Now we're done.
Plus idiots.
Any questions? All right, do the rest of the classwork.